All right, thank you. So, welcome everybody first to this presentation about the Pockets Portal main companion, the Portal API. So, without any further ado, let's start. And this works. So, first things first, hello, my name is Roniel Valdez. I'm a backend engineer at Pocket Network, mainly specialized on the Portal API architecture, as you will see in just a few minutes. Or as I like to call myself, I'm the guy who tries to make the Alex Chris ideas come true. So, also, besides that, I work in so I build on the infrastructure side and DevOps, but mainly only simply as a companion or helping when there's an issue with the Portal API. So, and one last thing, I'm also Dominican, so pretty grateful for all of you coming here, especially the ones from the other countries. So I really hope you're having a really good time here. So, to get into the topic, here's first an agenda of what I like to cover during this presentation. The first thing we want to talk about is well, what is the Portal API, how it came to be, and sort of the main features that it has. Then we're going to be going through sort of the life cycle of a relay and what goes through when the user and end user try to send a relay to the Portal API. After that, we're going to start talking about some of the scaling strategies that we use in order to stay performant, especially with the upcoming number of relays that we are getting lately. And after that, we're going to keep talking about more performance strategy that we use. But this coming in the form of sustainable services that they seem to happen outside the Portal API to be running independently. And lastly, we're going to start talking about some of the things we are planning to do in the future for the Portal API. So, let's get started. We're going to start with a little bit of history. I'm going to start with an honest fact, honestly, that connecting to the Pocket SDK is not easy, although our new version made it much better, as you're going to see in the next presentation. But still, the direct connection to the SDK requires maintaining two important things that may not be easy for everybody, and that is first, maintaining the Pocket's application's AAT, and second, handling the logic of the ever-changing station nodes. This can be a challenge, especially for new businesses or new startups that don't have the resources to maintaining them by themselves completely. Also with that, historically, when we first launched mainnet, one of the first clients, my other wallet, it also implemented a wide list of chains to connect to. So that basically rendered our SDK useless because by that time, we didn't know, also even now either, we don't know beforehand the addresses of the domains or the nodes that are coming within a session. So we had two problems that needed a solution. Hence, the gateway came for a solution of those both problems as a no-houseless way of connecting to the blockchain for whoever wanted to without ever needing to maintain the Pocket's application AAT or the section of nodes, and other results coming from a single domain. So those problems were solved, and we were able to move forward. But that came with a cost. In the end, the API is a centralized piece of our decentralized infrastructure, and we always try to favor decentralized options. So even though the Portal API exists as a centralized part of our infrastructure, we're working for developers to always have the main option of connecting themselves directly to the SDK and maybe shortly in the future, able to import parts of the Portal API by themselves. And the best way possible that we are dreaming on is simply importing the whole API, running the developers themselves, and getting the results from that. So they can enjoy all the features that are unique to the API while also keeping themselves decentralized. So, what's the Portal API? Well, I'm going to repeat myself just a bit here, so I'm sorry for that. It is firstly a developer-friendly way of performing relay requests with the Pocket's network of nodes. We don't have a Pocket's blockchain. In the end, all the relays that are being made go to a Pocket blockchain, not from Pocket. It also, just like I said, it also has the Pocket session mechanism and focus on relaying requests to the user. So application developers especially can forget all about that and simply focus on relaying the relays by themselves, getting the results themselves. It also provides a single URL per blockchain to connect to the RPC. That is also the same URL that we actually get when you create a new application from the Portal's website. And also, it's compliant on these JSON RPC responses that make it compatible with popular blockchain libraries such as EtherJS and Web3. So, all said before could be simplified as an API where you send a blockchain request and get a response. As simple as that. Going on with that, so with that said, the Portal API is no more than a companion for our blockchain developers to connect to the Pocket blockchain of nodes, while also enjoying some of the new features that are specific for the Portal API. Some of the features are that you can connect your applications and configure who can access to the application that you just made on the Portal website. You can configure from the user agents, the contacts and methods that are allowed to go through, and also also the origin, sorry, that are able to go through your application. Also, besides that, we also provide node stickiness out of the bots. Node stickiness is basically a way for all your relays to go to a single node to a certain period of time. And that is especially useful for applications that have two things, high throughput, and they have high fast block time. So for example, if you have an application that has a very fast block time and a high throughput, you're gonna be, if you start sending many requests to many different nodes, the data may not be propagated that quick into other nodes, so you may be running into different issues because of doing that. By sending out a request to a single node for a single period of time, you're able to lower the possibility of getting those issues. Also, we ensure to have the best latency on each session by measuring the speed of every relay with a service that is commonly known in the community as a cherry picker. It basically rates all the nodes based on their speed and latency. Lastly, we perform a quality check on the nodes to avoid sending relays to the nodes that are either failing or not passing the quality checks that we perform on them. Basically, much more features that we made to get the best performance as possible. And so, there is a single question with that. Okay. Where does all of that run? Well, we use plenty of tools to basically run our applications on the Portal API. Right now, our main programming language that we use is Node.js with a framework called Loopback. But we only use Loopback for basically handling the request response lifecycle of the servers. All the other code from the Portal API is being made using pure TypeScript. After that, we are use Redis for caching, basically. We try to cache things like the session data, the unhealthy nodes, and things like that. We also use MongoDB for getting mainly for historical reasons, for getting our database data, but has been proven to be quite useful because of the native that it has with a JSON-like structure. It has been proven to be comparable very easily with Node.js. Also, we use PostgreDB and Influx for metrics data. You can know that because of some of the server that we run for the node runners to get the error information. They are basically being running on top of Postgres. Lastly, we use the Golang development language for running some of our standard services that you're going to know a little bit more later. On the infrastructure side, it's quite simple. We use Docker for containerized deployments. We also use Terraform for making our infrastructure as code. And our main cloud provider at the moment is AWS. So, without that said, let's see how we put it all together. Here's basically a representation of how the blockchain really works. There's supposed to be the source code of that image right there, but you can see it on the diagram. So I might send it to you later if you want to see in more detail. I know you can see all the details right there. But basically, those 5 steps are those that happens. The first thing we do is that we try to generate a session on the Portal API using a set of servers that we have that we call dispatchers. Those servers are no more than a set of Pocket nodes that we use to only perform the dispatch operation, which is the operation that is made in order to generate a new session. After we basically have the session and the nodes of that session, we start performing the quality of service checks on all of those nodes, discarding those that either didn't respond on time or maybe had or answer with a wrong answer, whatever that is. Moving on with the valid nodes, we start choosing the node that is going to be performing the actual relay request. And we do that with a service that is called the cherry picker. But I'm not going to be talking more about it. If you want to know a little bit more about that, you can check on Al's presentation later today. Let's say that we already got our node chosen from the cherry picker. Then the relay is being made, after the response is being returned back to the user. There's also one last optional step that may or may not happen, and that is when the relay actually fails for any reason. So we then try to do the relay again with an altruist node. An altruist node is no more than a set of Pocket nodes that we use in order to perform relay responses as a backup. One thing important to point about those is that the altruist nodes are not actually staking on the Pocket's blockchain. They don't earn any kind of rewards. They're simply there to serve a backup if a relay actually fails for whatever reason. With that said, the relay is done and we just mint our new NFT or we just got a deposit from an address. Basically that. And as you can see, the architecture of the Portal API, the overall architecture is quite simple. There's not a lot going on overall, but that is made on purpose. As we're going to have a little bottleneck as possible and focus on relay as many requests as we can. With that said, I'm going to go a little bit of detail into the second step, which are the quality of service checks. So, we currently have several types of quality of service checks. These checks are performed at the node of an anti session. Yeah, the notice session is a session that is being used by the portal API. And these are run every 5 minutes for all the nodes on that session. Each of the checks only return the nodes that pass such checks. In order for a node to be eligible to perform relays, they need to actually pass all the checks on time. Also, there's one last thing about that. In the unlikely case that all the nodes within a session fail for any reason, the session is being marked as a failure. And for the next 30 seconds, then all the relays are going to be made only using all trees. And then once those 30 seconds are over, they're going to be retried again using performing the checks again first. That is to give the nodes within that session a little bit of time in order for them to recover. So, our first quality of service check that we're going to talk about right now is the chain check. And this what it does is that it ensures that the session knows that it's actually serving the chain that is being requested and not any other one. That may seem unlikely, but it can happen for plenty of reasons. Let's say, for example, we are a node runner, and we're planning to set up a set of Pocket nodes, and some of them are in different chains. And we, for any reason, for any misconfiguration, put the wrong chain on the Pocket node, the wrong blockchain node on the Pocket node. So, for example, on this, we can see that the Avalanche node is being served in a session that is related to Ethereum. Nothing against Avalanche, I just put it as an example. So on that case, we do want to be sure that we will actually be able to serve in the session that is the chain that we are trying to get, is that we perform a test relay on all the nodes in that session and try to get any identifier for the EVM chains. And for the other kind of chain, we try to observe a method that returns any kind of EVM unique identifier. We compare that against the actual ID of the chain requested. If they differ, then the nodes are being discarded from the session. Our second set of check that we perform is called the scene check. This one, what this does is to actually assure that the chains that the nodes within a session have the height that is good enough for the chain to be able to perform well. And for this, we have two sources of truth. The first one are the nodes within the session, and the second one is an altruist node from that is being assigned to the chain. The way that this works is that we first try to assure what is the biggest the node within the session that has the greatest block height. It could be either the altruist or one of the nodes. When we are sure which node is that one, we then try to compare the difference of all the nodes against that one, and then we discard those that have a greater threshold than the one that is allowed. It can vary per chain. As you can see, for example, in this case, we got a block height of 200 on the altruist node, but one of the nodes in the session has 202. All the other nodes pass the scene check, the second one. But the third one has one lower than the threshold that is allowed, which is 5. Basically fails. It's discarded from the session. And lastly, one of the second checks that we perform is one that is called archive check. This one is different from the other because it's only applied to archive nodes. And that is because what we do, about that one, is that we ensure that a node that I'm being serving that chain is actually an archive node. And that is mainly because an archive node in the configuration style is no different than a normal node for a chain. It's most of the time, it's not all simply a parameter of the chain, of the node from that chain. So what we do in this case is that we try to set a test relay on a very old block, usually the first block. And we try to find if within that chain, the node actually failed for an error that is related to maybe not having an archive node. And if it does, then we discard the node from the session. As you can see, currently this check is implemented, but not in the API. I think it needs more testing, but it might be activated in the future. We probably need to make sure how to work with non-EVM relays, in this case, EVM chains. So, moving on to some strategies that we use with the portal API. We first take a lot of advantage on the horizontal scaling. One of the things that we do is basically on our cloud provider, which is AWS at the moment. We are currently deployed in 16 regions in a shared nothing architecture, which means that basically all the regions within our cloud provider, they don't know anything about the other one, and they have other resources they need within themselves. So they can actually work together without, again, knowing anything about the other regions. They give us two main advantages. The first one is that we're able to give the user the best certainty on the API and nodes based on where they're actually located. So for example, if we have two users that are connected to the same application with the same session, let's say one is located in Asia, other one is located in Europe. The user located in Asia, based on the cherry picker, as a different cherry picker from the one located in Europe, are going to have nodes from within that session that are closer to them, and therefore we're going to have better relay response time for that user in Asia. Otherwise, the user in Europe is going to have better nodes that are more close to them in Europe, and therefore having less latency based on that, as those two are working completely separate. And the second advantage that we can get is that we can actually provide a failover mechanism on the nodes, on the regions in this case. That basically means that when, for example, if for any reason a region fails, then we are able to automatically quickly switch to any other one, and it's going to result in a slightly lower response times for the user, but that is much better than no service at all. Also, from those 16 regions, we have 4 of them that are being marked as candidate regions. Those are simply deployments that are able to change to a different Portal API version. And we mainly use that for testing new features and making sure that the code that we are going to deploy is actually safe and not going to break any other things that are currently running in production. It's basically a way for us to set production before actually pushing to production. So, moving on with scaling strategies, the first one that we use is caching a lot. We try to cache everything we can and everything that is possible to cache. That could be database lookups, sessions data, invalid nodes, everything you can cache, you name it. So one important thing to take into account because of why we do all of this is that one thing we can never cache are the relay responses. We need to be able to send the responses to the actual blockchain nodes for them to perform the relays and earn the rewards. And that makes it different on the strategy that we use on caching because, for example, a centralized provider could benefit from some caching the responses, so you actually don't need for the nodes to respond, as they don't have the same economic incentives that we do for performing the relays. Also, as I mentioned in the previous strategy, all the Portal APIs in the same region share the same regional cache instance. So, for example, if I perform a session check in one region, then all the instances within that region have access to that data as it's being shared for all of them. They have to be done only once. Moving on with that, another thing that when implemented as much as possible and we started looking at numbers, we realized about something. The number of time of the relays were up to more than 100 milliseconds, only performing cache lookup requests. In the end, that makes sense, because as much as we try to rely on that, performing hundreds of thousands of other requests per second to a single Redis server in every region is bound to have performance issues, basically. So after trying and error some ideas, we came to the solution of having a local cache container being deployed along to the Portal API container together. That is called a sidecar in the form of a cache. So every time, what this does is mainly 3 things. When we try to get a cache value, the first thing it does is try to find it on the local cache that is being bundled outside the Portal API instance. If it does find it, then it returns the value back to the API and everything's done. If it doesn't, it tries to look it up on the regional cache, and assuming the value is there, it brings it back from the regional cache, and then save it on the local cache and return it back to the API. So next time it needs it, it just look it again on the local cache. This gives us many very good advantages because right now, operations that we try to perform the local cache are much faster because they are deployed basically alongside the Portal API instance that is requesting to the data. And that gives us more space for the regional cache instance to basically have more space and room to perform the other requests with more speed. Also, one last thing to point out is that the local cache is flexible enough to save the data for a fraction of the time of the regional cache. So, for example, if the value is being saved for 4 minutes in the Portal API regional cache, then it's only going to be saved for 2 minutes in the local cache. That is to prevent inconsistency between both of them. Moving on the external strategy that we use, we have some strategies that involve services that are not within the Portal API servers or code. Some services perform operations that assist the API instances, so they have to repeatedly do them during a relay and basically take longer time to return the response. 2 of them are what we call the global dispatcher and what we like to call the B0 fisherman. For example, starting with this one, which is a global dispatcher. But before talking about that, I first need to talk about dispatch operation. This operation that is being made to get just like I said before, decision of an application. But it has 2 important points. The first one is a complex operation against a Pocket node that it may take several seconds to get a response from, no matter how fast the Pocket node is, because it's really hard on the node, and we need to perform many mathematical operations. And second, just like I said before, with the shared node architecture, the request of session application needs to be done at least one for other regions. But again, they're only going to give us the same result. So we are thereby wasting time trying to request the same data to get the same results. So what we did in this case is we brought the global dispatcher that we perform the request only once for all the application for a session, or for the most popular application in this case, and then we push the results to all the Redis regional instances. So the Portal API simply takes the result as any other cache value. One thing to point out is that saving the results as another cache value gives us another advantages. As in this case, if the API for any reason, let's say the global dispatcher has an error and is unable to provide the results, then the Portal API simply returns the response, simply does the dispatch call by itself as it did that locally. So in case of error failures from the global dispatcher, the API won't mind about that. If we want to perform the work, it's going to have a slightly lower performance, but again, just like before, much better than no service at all. Okay. The second service, or second standard services, let's say, is that what we like to call the B0 fisherman. And this is one way to perform the quality of service checks that I just mentioned before, the scene check and the chain check on this case, on the most used sessions. So what a fisherman does is, just like a robot dispatcher, it takes the most popular applications being served on the network, it runs the quality of service checks on all of them, and pushes the results to other regional cache on all the regions, basically. That gives us another advantages because especially on speed, as relays that perform checks take a lot of time, they could take up to more than 5 seconds, but now with the robot, thereby slowing the final result time like by a lot. When you start, for example, get a new application and you perform your first relay, then the first that you perform, you always seem to think that it was much slower. It could take maybe 8 to 10 seconds, but because it was performing all the checks, so your first experience using a Pocket application wasn't going to be really good. That's not going to give a good impression. Now, with a global dispatcher, the session applications check, the quality of service check, is basically invisible, and you get the fastest response time possible from your relays, just like it happened already the session nodes. The session nodes checks results. So, this is the last part of the presentation. What is the future of the Portal API? Here I'm going to talk about some of the short and middle-term things that we are planning to do. To start, our most ambitious project at the moment is the full request from the Portal API from JavaScript or TypeScript from Golang. That is especially coming because of a plethora of reasons. One of the main ways that we made an internal advantages of our internal team to use Golang whenever possible. But in this specific case, one of the advantages that we're going to get is to reduce the deployment costs, as we're not going to need less instances to perform the relays for the same amount of traffic. And second, we're going to be able to get the throughput of our applications or for API instances, because we're going to be able to serve more relays in a less amount of time. This is especially useful for applications that are very intensive and process a lot of relays. But honestly, besides all of that, we simply love Golang, so whenever we can use Golang, we will try to use it. Another migration that we are doing within our team is the one from our MongoDB database engine to Postgres. As the Portal API schema barely changes and is free read only, using Postgres in this case will bring more advantages along with aesthetically typed languages such as Golang. Also, we're planning to be even more creative with our standard services. For example, this has been a huge addition for us that has been quite new. And this has given us the advantages of treating all the regions of AWS as one and perform operations on all of them at the same time, at any time. We're still brainstorming on ways that we can take advantage of this. But for example, one of the things that we're working on at the moment is a service to give node runners more data along how their nodes are running with the cherry picker. Last but not least, we are planning to migrate the deployment from pure Docker with Amazon ECS to Kubernetes. And these will have for several reasons. The first one to have more control or finer control from deployments, the lifetime of the instances, and even more. And second reason that we're trying to move from the standard service that we're running right now, such as the B0 fisherman and the global dispatcher, from vendor locking services to Kubernetes. Because for example, we're running right now the global dispatcher and B0 fisherman on AWS Lambda. But we much rather run them instead of a serverless environment to run them ourselves within a Kubernetes cluster. So, there's one last thing to say. What, for example, you blockchain application developers, users, basically anyone using the Portal API get from everything that we're doing? Well, what we're always trying to achieve, which is better service, faster relays, and even more throughput. Thanks for coming here. I just wanted to say one more thing that I forgot to put into the presentation, and is that this is the Rebel for Reporter API. You are very welcome to go, especially if you are a developer. You can ask questions there. We're always there. You can open up issues, and it's much better try to open up pull requests. We're definitely going to try to check on it and try to help you as much as you can. Everything is open source. We will be really happy if some of you try to get into there. Only at least to check on the code. Thank you. Yeah, I'm sorry about that. That was automatic. Yeah, anybody got any questions? Yeah, you can go ahead.
You actually we're waiting for your API to get some information. We are on-premise and we want to get more intel about how are the relays going to, I know it's chosen by the session and then the relays I give it to some node by some reason it's the cherry picker. That will be our job. But you will be releasing data about the information that is using the cherry picker. What kind of data are you planning to give us and when it's going to be?
You gotta check all the stack for that. He's gonna start right about that. So yeah, I don't want to spoil his talk. So, but really, you wanna know about that? You wanna talk the function that you made? He's gonna talk about all of those. I can. I'm writing, but yeah. But yeah, just to give a quick pick on that, we're basically trying to get all the using global services. Yeah. We're trying to take a snap of the cherry picker data for every X amount of time, aggregating all of that, basing a rank based on how many sessions are in the nodes, and taking information such as the average time of the request, the aggregated median time for all the requests being before a node, and more, let's say, specific information regarding that, and expose all of that on the form of the API so users can take from that.
It's literally the exact information that the gateway uses to determine the rankings. You're going to get that exact dump.
Yeah.
Data. If I was, for example, my node was excluded due to I hadn't seen, would we get that information also?
You already can get that information from the Postgres errors database. Yeah, this information is different. It's the information that, for example, how your node is performing against the cherry picker. For example, let's say that you have a node in Asia, and you can say how fast it is against the other nodes within that session. Is it better? Is it worse?
And it's not just a latency response, it's a test of your load as well. So it shows you how your node is actually doing the session. You can take the JSON output from that and literally put it into the cherry picker code that's open source and see how it would rank those nodes.
Yeah, definitely.
Full transparency.
Information about other nodes.
Yeah, you also want to be able to get information about the other nodes.
That was in your session.
You're going to get about other nodes on the session, basically. From yours to all the other ones. So don't worry about that.
That will be, it's not available right now.
No, we're actively working on that. Well, I'm the one working on that. I'm here, so hard to code while I'm presenting something. Yeah. Well, yeah, we're working on that. I can show you that. Yeah. Any other question?
How long is quality of service cached for?
It's for 5 minutes, yeah. Basically, when the cache service is expired, it tries to do it again.
I assume the biggest competition advantage would be latency, right? How much or how big of a role is if my node gets unlucky, for example? I get a lot of errors for chain height, but for pocket chain height. For example, I get relays when my node already is showing the highest block, but still not finished syncing or loading it. And basically my relays won't go through. So let's say I get a lot of errors in a session. Does it invalidate me to get into other sessions, or it doesn't even roll over to sessions? And only the latency is what mainly we should focus on.
I'm going to respond assuming that you are asking about how much does it affect block height errors on your node. To get that's what I understood. So yeah, sometimes we have working issues right now that sometimes broken nodes, such as the one that you mentioned, may get outdated for any reason, but because they're not finishing, maybe you calculating the data that they need to get to the next block. But again, first thing first, we're working on that from the protocol side. But second, if the node height is not that far, I think we need the same session, then we'll still be able to perform relays, and they won't fail due to, let's say, invalid block height errors. So they're going to be effective for the CJ to be incomplete, taken away, or for the change check for being served for saving the ground session. In this case, that's not going to affect anything at all. But if they do get the error that we are actually having metrics on that, and it's quite low, that almost never happens, it's going to be taken out completely because it's going to be shown as a failure.
Wanted to clarify to him. I think he was worried that if you were failing in a session, that in future session, if that was going to punish you.
No, that,
Not punish me, but like invalidate me to get in future sessions.
no.
That's not like that. Once you are included in a new session, that's like completely clean that you're not, like.
You're a new guy. we don't know you, but you get into a new session.
The experiment with longer lived checks, and it was just punishing for the noise. Right? Like it wasn't fair to not let you back into the session, so it was reduced until it was the right granularity, I think. But back in the history of time, when the quality of service checks were first implemented, the network was a lot worse. Like the nodes would fail for hours or days at a time because people weren't paying attention to them or they were bad at running them. So that it did used to punish you for a lot longer, but as the network got a lot better, the DevOps providers got a lot better, people were recovering their nodes a lot faster, I reduced that time that the quality of service checks lasted so that you can get back into the session.
So, for example, that's a very important question on that. Although the portal API checks are being made every 5 minutes, most of the sync and change checks that are being performed are like 95% are being performed by global fishermen, P0, and those are said to be done every 3 minutes. So it's faster for you to get into relays again. So you fail, for example, the sync check for whatever reason, and then you get into sync, you're only going to need to wait 3 minutes at least. And then you're going to get back and get on track getting relays.
You kind of have a related question in there too, that if you fail for one chain, does it affect you for other chains? The answer is no. It's very chain
Yeah,
specific.
that's also interesting, but probably not because it's a different chain ID, right?
Yep.
Yeah.
Exactly.
Yeah.
It's all chain ID specific.
And if I may have another question, more from a user perspective, I noticed you mentioned checking for archival nodes, even though it's not implemented yet, but what about tracing nodes? Because those are even more scarce than archival nodes?
They cannot, well, I'm going to talk about EVM chains in this case. We still haven't got a full solution for non-EVM chains. But talking about the EVM ones, they basically have a specific error code. I don't remember right now which code it is. But on that code, you try to perform a relay or try to get a very old block information. They fail with that one, whether it's archival or archival with trace. They fail with the same node. So the same check can be applied to them. We simply, send a relay, test the result, and if we got that specific error, then it's not archival, and we take it out.
But he's right. We could go more specific on our account check to say we need a trace check.
Yeah,
If
yeah.
they're running Parity or Aragon with the trace feature.
It- Do you know what I'm going to say about that? You know the first thing you can do for that? Open an issue. And we'll get back to you, definitely.
Well, it's so modular now that if you actually
Yeah.
wrote that trace check, all you have to do is read the archival check, figure out that difference in the column, and it's just a simple PR.
But yeah. But again, open an issue.
Please, you could actually be the first outside contributor, I think, to the API.
I'm sorry.
Are there any plans to diversify the origin of the quality of service checks that are occurring?
Sorry, I can hear you.
Are there any plans to diversify the origin of the quality of service checks that are undertaken? Because, it could be that a given network path is degraded by particularly if you're centralized in AWS with those checks that penalizes people that aren't in AWS, for example.
We haven't thought about that, honestly. But yeah, it can be done. It's a very good idea. We can try to do any other ways of performing the checks because in the end, they have actually worked for us so far at the moment. So we didn't even think about trying to check them. But just like you're saying, they could be penalized if they're not within AWS. But that comes with also one of the things that I mentioned, Alice, in the earlier presentation, that once we get outside from AWS, then we don't have that kind of, let's say, latency issues because we're going to be running on other kinds of cloud providers. So yeah, it could be taken from both ways.
It's kind of a walk before we run thing, in that we got this implemented first on AWS, and we're very much tied in now with vendor lock-in, and we're going to extricate ourselves from that. But that vendor lock-in means that when we're trying to communicate with these cache instances that he was talking about, we have to go through our VPC. We're in a private VPC. We don't have the exposed level, so we have to get to a private VPC with AWS network. But that's all going to be extricated in the future, hopefully, as we go.
At the same time, like the cherry picker has this thing that almost like you have an economic rate, that's a nice
Just to let you know, you can say on the code, or right now, the threshold of time, or the timeout time we have on the check is 8 seconds. So you're not able to respond within 8 seconds, that it has issues. Yeah. I wouldn't want that no serving my relays. Any other question? Any other question?
I have just like a
Well, let's go to the guys in the back first.
How often does it ever happen in which there's a session where all the nodes fail?
Honestly, from what I remember from the logs, almost never. It used to happen more often when we only had 5 nodes in a session, but now we have 24. It's like almost impossible to say that all the nodes are going to fail. There's like at least, let's say, more than 5, I could say that, more than 10, or more than 10 that are working fine for a session.
Is there any plan to include challenge transactions or another, like let's say a node passes through the gateway checks but still returns old data? Is there any other punishment?
For the challenge part, okay.
Some interesting information. I started about it, but I actually didn't know how challenges worked correctly. Like I found out basically that they are too punishing right now to implement. That I want to work with them for a revision of V8 where the challenges aren't so punishing. The challenges are actually punishing enough right now that they are meant to take away your entire possibility of rewards for that session. So if you answered one thing that failed the challenge, you could be penalized from anywhere from 300 to 500 pocket if it was one of the giant sessions, which is a horrible, horrible slashing penalty. Like that's far too harsh. That can actually knock most nodes out of the 15K range, right? Like if you're slashed 500 pocket, that's going to knock almost everyone out of 15K. You're going to get unstably slashed completely. So no challenges are implemented. I'm going to be working with the protocol team to make that a much nicer slash because it's a ridiculous slash right now.
But we do have the code there. It's simply not activated. But you don't need to, basically uncomment the code. It could be set in developer terms and activate that. But you don't want that at the moment. Any other question?
Again about the latency, I noticed Torchain is also having this kind of issue that all of their validator set is basically concentrated in three data centers, basically 3 cloud providers. And let's say we have this latency fight, right, in between validators, but those who have the best opportunities would be co-located within the same AWS data center where both workloads, and it's not really incentivizing running our own replicas or running our own.
So, Brandon, I don't want to interrupt you, but this is definitely a problem. This was definitely a thing.
So the question is like if you already have some, I'm not saying like already have some plan, but like
No, it's already implemented. It's already implemented. Come to my talk later, and I'll talk about what that is. But basically, the cherry picker ranks you in the top bucket if you perform under a certain threshold. So I definitely saw what you were talking about, where nodes that were on AWS were just slightly faster than my bare metal that was next door. I had bare metal in Frankfurt. I was comparing them to AWS in Frankfurt, and just beating me by 5 or 10 milliseconds was very significant at that level because we're like 40 millisecond to 50 millisecond. Well, that's a giant level for that's 25% of the time more. So the cherry picker was actually penalizing that 50 millisecond node quite harshly and putting all the relays to that 40 millisecond. So what we have now, I call it top bucket smearing, which just means anything under a certain amount, you're all top bucket. So if you're in Frankfurt, you're top bucket, whether you're on DO, bare metal, AWS, anywhere else.
so there's like a tolerance for.
That's all, exactly. It's tolerance for the
regions.
top bucket.
Yeah.
Yes.
Okay.
Because it was definitely over-rewarding AWS, which is not what I want to do.
Awesome. Thank you.
Go to Alex talk. You know everything about that.
When was that? When was these videos? 6, 10 months ago? It was wild.
No, I will say 3 to 4 months ago, I will say.
Mine must kind of be.
Yeah, give or take. To the right side.
Could you go over the distribution of relays depending on the bucket? Like how much worse is somebody who's like serving an 800 millisecond relay that's in like across the world compared to somebody who's.
So I would love
Again, cherry pickle talk.
I would love someone for you to write that tool. Once you get this API data, you're going to be able to produce that. So take this API data, cross it with the portal API cherry picker code, and you're going to be able to produce a distribution graph of how many relays went to each node based on latency. You can also determine that just from looking at the algorithm that the cherry picker uses, the weighting algorithm, to say, you're in this bucket, this bucket, this bucket. You can form that curve just from looking at the code, but you'll actually be able to form those curves
Yeah, when we provide the API data, you'll be able to graph all of that.
I mean, it's hard to describe because it has a couple different weighting factors. It weights your P90 latency, it weights your medium latency. Yeah, it's hard to describe in curve form, but it's like, I made it harsher recently to try and improve our P90 performance. So when we went from 5 nodes to 24 nodes in a session, that gives me a lot more room to work with those nodes, right? 5 nodes a session, I can't really exclude them. I need those nodes in the session. When we have 24, I can dump 15 of them most of the time, right? 15 of them are going to be so geolocated badly for this session, for this client, that there's no reason to even bother them. Those top 8 or top 5 nodes are really all we need for that session regionally, because each one performs different regionally. So the top 5 APAC nodes, top 5 EU nodes, basically if you're not in the top 10, you're probably ignoring them.
And again, your single node will never be able to perform well on other regions. You gotta know in Europe, you're gonna perform worse in America and Asia.
But that's why we've caught up with Infura and Alchemy now in our median relay times, is because we've been able to make that curve a lot harsher now. That we used to have to deal with those slow nodes, but now with 24 nodes a session, a much bigger network, we don't have to tolerate that slow service because we can get better service from the companies.
You can make a question then?
Let's say you're an app developer and you're looking for like really a secure relay and accurate data. Is there any plan to implement sort of consensus relays in the portal API? So where multiple nodes, for example, let's say there's 24 nodes in a session, it queries 16 of them, and then gets the consensus of what all those nodes return to get more secure data.
Yeah, like for example, like an exchange application, like where
Let's say you need to be 100% sure that that relay is accurate.
That thought is built into the protocol from the beginning, right? Like that's how they actually envisioned quality of service working from the beginning, was that it was all based on consensus. In the real world, unfortunately, that's very, very slow. And especially with only 5 nodes in the session, with 1 or 2 of those being probably very remote from you, it was really, really slow. Like your average response time was 3 to 4 seconds per relay, because it has to wait for everyone, right? Now with 24 nodes a session, it's actually much more possible. So with 24 nodes a session, we could say enforce consensus with 3 or enforce consensus with 5, and you're still going to get really, really quick responses. We haven't had anybody that's asked for that, so it hasn't been on our immediate roadmap. And it's only really been possible since it's 24 nodes in a session. But that is definitely something that was really, actually quite simply possible, really easy.
But again, just like engineers saying right now, there are pretty good ideas. Please, open an issue. I want to get back to you on that. I really want to do that because so you can into the portal API and see the actual code we're doing. So you can see that clearly what is actually going on.
These are the only guys that are reading the code that
I know.
Everyone asks you questions.
Yeah, I know.
But yeah, that's a really good thing. That would be a really super easy feature to implement per application or per load balancer. Tell me how many nodes you want in consensus, and then it initiates your session with that. Because that's built into the protocol. Okay. But again, with the challenges the way they are, we wouldn't issue challenges off of that, which is also what the protocol is.
Right now, yeah, it's definitely possible. I haven't been implemented, but yeah, it can be possible. But you just be aware of that. Maybe when you try to perform consensus relays, it might be a little slower, depending on how much.
It definitely will be slow. Yeah. It definitely will be slow. And in our mindset right now, we're in a race for speed and latency, and not necessarily for consensus, because to even get the attention of the projects that we want to get the attention of, our latency has to be comparable. But yeah, trivial.
Yeah. So it could be left as an option, the portal API, for whether you want it or not, up to the user. Yes. Any other question?
are like applications shared between regions? So like, do you have are application public keys specific to like one gateway region? Or they share?
No, they're all on the database that is basically all for all of them. They are shared between regions.
Your session is not regional either. Like your session and your application all are the same 24 nodes, whether you're in Asia, 24 nodes, whether you're in Europe, same 24 nodes.
And I wonder, it's like, say like an application generates a session, like in EU, is that session only going to originate?
No.
Are relays in that session only going to originate from the EU?
No.
Because you could generate that same session on your local.
Again, just like I said before, the sessions are deterministic. No matter what you ask for the session, whether it's Europe or America or anywhere else, you're going to get the same response, the same nodes for that session. So no matter what we ask for the session from any region, we're still going to get the same set of nodes.
No, what I'm asking is, are the relays for this, like for this session, an application key generates the session with 24 nodes. I get that the 24 nodes are fixed, but are the relays originating from one gateway region?
No, they originate from wherever the
Yeah, we don't control that. Basically, where it's closer to you.
Okay, so say my node is selected into a session. Within that session, am I only going to receive relays from one region?
No, no, from other regions.
From all regions. I mean, it depends where the traffic is. Like, there's that one X diagnosis traffic source we've been talking about. They're literally only coming from AP Northeast 1 or AP Southeast, right? So if your node isn't there, you're never going to see their session traffic because there's nodes serving it in Asia that you're not going to see. So some traffic is very regional, but that's just the traffic.
You get that value to get to our net?
The number, the amount of traffic per region,
Yeah, what do you like?
it's on a handy URL you can hit right now, traffic.research.pocket.network. And that's a live view into where the traffic is coming from and per blockchain.
I'm gonna, and I'm gonna put it. I'm gonna put it also on the Pocket Network Discord so you can check it out later. So don't worry about that.
Yes, there's
Another one? So, okay. Can you repeat? I'm sorry.
Is there any plan to expand the number of locations overall? So you've got like EU West, EU North.
Can you translate that for me?
Yeah, we're in every AWS region that we think matters at this point, and not only matters like about importance, but matters at a time. And yes, we are missing cities that we should be in, but we need to remember as part of our rules. We are in AWS MBA programs, so you get first access to regions that are fine. But there are major cities we'd like to go to government. But honestly, the latency isn't that far off. Like if you're in Netherlands, Frankfurt is 6 milliseconds.
I know in the UK it is a bit more difficult to know.
Oh, okay.
You've got like 10 milliseconds over some framework.
Oh, to oversee, yeah, if you're Dublin, and you use
I know, for instance, in the data centers in Dublin, I don't know if you use them. But if you had Dublin, for instance, maybe.
I don't think Dublin's in the US.
No, it isn't. It isn't.
Well, like GCP has Netherlands, and I would also like, but
Yeah. Again, any other question? Okay. Well, I'm gonna keep it there. Espérate, no tengo manos para eso. Thank you. Duro, papá. Gracias, gracias. Buena presentación. Voy a estar con el KPI,